Assalamualaikum dan selamat sejahtera guys. Hari ni saya akan membincangkan ataupun present my topic about economical section. So, what is actually economic? Economic merangkum pada semua environment. So, basically low cost, low use of environment, low use of material. So basically, kalau sebut je pasal economic, ni semua pasal low cost, low use of material. So hari ni saya akan terangkan apa itu maksud economic section. So dalam economic section, kita akan ambil a fact usual formula. Kita akan ambil flat usual formula, iaitu stress of bending equals to moment times y over I. So it's actually inside a very normal rectangular beam yang ada neutral axis kat tengah-tengah dia. So y is actually from the point of salah satu point. So let's say kita ambil kat sini. So y adalah distance dari point ni ke neutral axis. So maksudnya daripada sini ke neutral axis. So this is y. Okay. So daripada formula of flexure ni, we can analysis and take out all the stress into a graph that will looks like this. So the upper part is the compression and the lower part is the tension. So the upper part is the maximum stress compression and the lower part is the maximum tension stress. So to evaluate, from this flexure formula also, kita boleh keluarkan lagi satu formula yang mengatakan bahawa stress of bending maximum is equal to moment of maximum times C over I. So moment of maximum ni must be absolute, so we must put a modulus sign, because not all moment have a positive value. Sometimes it have a negative value, so we must put a modulus. And C is from the outer part, distance from the outer part of the beam to the normal axis. So in this case, inside the rectangular beam, we got up here from the upper part to the normal axis, and we also have from the lower part to the normal axis. So we got C inside the rectangular beam. So from this figure, we can analysis and realize that the most stressful place, or the most stressful places inside the beam is actually only at the up here and the down part. So we can transfer it into the so you can see that the most stressful part is up here and also down here. So we can transfer it into the beam. So the places that actually the most stressful is up here and also the lower part of the beam. So these two is the most stressful places that is very used inside the beam or very stressful inside the beam. So to make a beam is economical, we should reduce or eliminate the unstressful section inside the beam. So the normal rectangular beam is like this. So which one, the part that's the most stressful is the upper part and the lower part. So this type of beam is unpractical because it's not joining together. So we must put a support in between this stressful to make the I shape or I section of beam. This beam is called W shape beam or Y flange beam. So this is the part of flange and this is a web. Why I can say this type of beam is economical because we can see it that certain part of the rectangle beam is being removed and it's use less material inside the beam. As you can see, it's already eliminate certain part, which is this part and also this part of the beam, so it make the section is economical section. Economical section. So there you go. This is so now do you understand what is actually economic section? So I hope you understand, and if you have any question you can ask later on at the end of this presentation. Oh, before I forgot, not only I shape beam is economical, but there is a few type of economical section, which is an L shape, or in a T shape. It depends on what type of beam you want to use inside the construction, and to make it less cost and less usage of the material to make the beam. So I will end my presentation.
Okay, this is one of the example of the economical section for the I-beams. So the question is, select a proper A36 steel wide flank beam that will safely support the loading as shown. So this is the beam diagram which is given. That's it. So the free body diagram for the diagram given is this one. So as we know, everyone, so the shear diagram and the bending diagram itself is given. The shear diagram is this and the bending diagram. So from that we can conclude the maximum shear and the maximum moment. So the question is they want to select a proper 836 steel. Okay, as we all know. So this is a quick refresh for the flexure formula. The allowed maximum bending is this. The formula for allowed maximum bending is this, and the allowed maximum shear is this. Section modulus is IOC, and required section modulus is maximum movement over movement allowed. So we will go to the question. So we'll start off with the diagram. So this is the diagram. Okay, now the maximum moment that we calculated just now is 110 kilonewton per meter, and then the maximum shear stress that we calculated just now is 27.5 kilonewton. So if you see for the A36 steel, the maximum bending allowed is 22 kilonewton, and then the maximum shear allowed is 14.5 kilonewton, or else you can keep it as newton. So the section, therefore the section required modulus is moment maximum over bending allowed, which is 60 cubic inches that we have calculated and converted. So if we refer to this diagram, this is the direction for the founded section required modulus. So this is the value, the minimum value we have, and then the type is W18 times 40. So this is the best one we could take.
The first column as you
Since this is 60 inches cubic, so the best one is W18 times 40 beam, the selected one. So this maximum shear we'll write down again, and then shear allowed 14.5. Okay, now that we have to draw a I-beam, this is the I-beam. This is the I-beam. So the B value we have just converted into inches. Every value is in inches, so it's 0.315 inches, and then the length here is 6.02 inches, and then the height is 17.9 inches, and then this value is 0.5 to 5 inches. Okay, so this is the measurement we have for the beam right now. Next is we can calculate the area for the given beam, which is the area is the height, which is 17.9 inches, times 0.315. The B is 0.315, and we'll get 5.64 inches square is the area. So the average shear that we're going to find from the question just now, the allowed shear must be lesser than the provided shear, which is the A36 steel. So maximum shear will divide by the area, and we'll get the amount of average shear which is exerted on the beam, which is a 27.5 divided by 5.64 is equal to 4.88. Okay. So therefore, this is lesser than 14.5 from the allowed shear. So whereby our selection is a success. Thank you.